Okay. Very interesting, right? This is the kind of thing that is innovative. But it's not I create one. But if you want to know what is an innovative idea, then this is something which is innovative. Okay, so this is how the game works. Okay, you work in pairs. Okay, I'm going to give you one deck of cards later. Okay, I'm going to give you a deck of cards. And each pair gets to open, so you just put the cards on the table in a mess, okay? Face down. So this one is the face down. You will see organic reaction when it's face down. Okay, can you listen to instructions first? Yuan Ye. Okay, so then when it's your turn, then you open one card. Do you play Snap before? Yeah. It's the same rules as Snap. Or if you play ugly dolls before, it's the same. You never? That is such a new game, eh. Then you will say ugly. Okay, so when you tap on the cards and the reagent and condition matches with the reaction, so I give you an example. So, like for example, okay, if I have this and this, what is this reaction? I show Iza. Is it electrophilic addition? It is. It's not elimination. It is addition, but is it electrophilic addition? No, you haven't learned nucleophilic yet. This is just addition, it's catalytic addition. You remember for alkenes one, you cannot, if you are adding H2, you do not say it's electrophilic addition. All others, they are electrophilic addition, but this one is just addition, because this is catalytic, okay? But you don't need to write catalytic addition, you just need to know it's not electrophilic addition. That's why it doesn't follow the same mechanism as your electrophilic addition. Okay, so once you open and then you see they got two cards which matches with each other, then you will tap on both cards at the same time, then you will say react, okay? Okay, this was being tried out before already, so I'm very sure this game works. Alright? So, yes. No, I did this when I did my practicum in 2014 for my pre-U graduated batch. When I was having my practicum, I did this game card for them. Okay, so I'm going to give each group. Okay, this group you play at the back, okay? Then this group, can you come in front here? Okay? And then that group, you can just turn back. Or you come in front, easier, more space.
That's the way.
That's all. In pairs, so you all can stand out. Okay, can you all stand out and then at the back there? Faster, no time. In pairs. So just in three times, go 3 times. Or if you want 6-person play also can. But you will be anything. Okay, faster. In pairs, so like for example 1, 2, 3, then Jing you can play alone. Then after that you will open. You open because odd number then you open, okay? Raj, what are you doing?
How you play it?
Ayo, you all know how to play or not?
Yes. React.
You close first, yeah. Okay, close first. Okay, so play on this table, okay? No. Okay, so like that already, right? Yes. You must put all like that. Then after that, you can just open. So you can don't do in pair, you can just everybody go one round until you see a pair that matches. Then you will say ready. Okay, I give you 3 minutes for this round. You can start already. how come you all cheat?
What is this? Why you do like that?
No, you're supposed to.
Yeah, we're supposed to open two of
Yeah,
that.
open one by one. Faster.
This one win already.
Okay.
Win already.
I win already, you keep. Okay, hurry up.
Remember, it's not equals.
Okay, you faster.
That one was the equals one. Equals me. What you do, your friend never do.
Can you all don't argue over small matters, thanks? Very childish eh. Don't need to close back. It will just be there. You don't need to close back. Hey, you don't need to close back one, you know. This is not memory game. So you just open, then after that anybody who see is correct, then you will just react.
Not fair. The cut outside right.
You must go faster or else very slow. Oh, you finished already? Oh, so fast. So who won?
We
do teamwork.
No, you must have one winner. What?
Then we see who got the most bad.
Yeah, correct.
Oh, now I got.
Yeah, correct. Yeah, correct.
Then we haven't end the game.
So who won? But when you say react, it should be the same pair already. It should be the correct pair already. You know how to play one or not?
Jojo must be flexible. Improvise your game.
Okay, I think your group is the best. Okay, are you done with first round? Okay, faster. Okay, I give you 2 more minutes. Okay, so you won. You want to play one more round for 2 minutes? Okay.
We play like legit.
Yeah, don't cheat lah. Hey, how old already still cheat? So who won?
Good game.
He won Oh, probably win. Okay. Once you are done, you can keep already. You can keep the cards.
No round two.
Okay, I give you 1.5 minutes for round 2. Okay. Don't mind. Okay, then you can go back to your seats already.
One cut pay $5.
Faster. Can you? Where's the rubber band?
Thank you.
So who won? Still you Hey, they got A. Hey, what is Amy and Ray and Jing Yu doing? How come so little? Okay, can you keep and then give me back my cards? No time already Okay. Okay, Gwen, your group, hurry up. What? Just started. But they can finish in 2 minutes They just started also. Where's my rubber band? Where's my rubber band?
You never give away.
God.
Never, you just
I
put
gave
away
you
down there.
your tissue paper.
No, it's tissue paper. Yeah.
Where's the rubber band? I never give you.
Never, just give me the thing one.
My rubber band? Go and find my rubber band. You stole my rubber band. Okay, thanks. Okay, you can. Hello. Okay, are you a bit more awake now? Are you a bit more awake now? Okay, so how do you find the game? Fun, right? Too simple. So if I add other functional groups, are you sure you are game on? Okay, so now let's go back to our phenols from where we stopped. Alright, now using what we have just learned, okay, I want you to do the AB. You want B first, okay. B to A. Can you explain the acidity of Okay, I don't give you such a difficult one. Okay, these two compounds. Okay, I give you 1 minute. Can you think first? These two compounds. And then how are you going to explain the acidity? Alright, I give you 1 minute. Okay, I want you to write down in your exercise book your answer if I want you to explain the relative acidity of this as compared to this. So explain the relative acidity of ethanol as compared to phenol. Can you write it down in your exercise book? I'll get someone's script to show. Okay, ready? Don't need to write stories, you know. You just need to say, you just need to have those steps and then tell me why is it that one is more stable than the other one, and then conclude which one is more acidic. All right? Don't need to write stories. When you say one is more stable than the other one, you don't need to tell me why the other one is less stable than this one. Okay? Which means you only need one reason. One is enough. So, for example, if you want to say the electron donating factor, okay, to say that this one is less stable, the conjugate base of this is less stable than the conjugate base of phenoside, then you just write that one as your reason. Okay? Yeah, correct. So ultimately, we just want you to have a reason for why is it that it is more stable than the other compound, the other conjugate base. Of course, if you have a lot of time, then if you want to write more, no one will stop you. But the more you write, there could be more mistakes also. Okay, if you use the terms wrongly, there could be more mistakes. Okay, are you ready? Number 16. 为什么 16? Okay, Renita, can you show me using? Can you show me your work? Okay, can you look at her answer? Okay, I give you 10 seconds to look at her answer, and then you tell me whether you agree or disagree with this answer. Ready? Can you show me using an ice cream stick? Do you agree or disagree with this answer? I say look, then you never look, then now you look. Then everybody waiting for you to look. Okay, so, okay, all of you say it's true. Okay, so what is the first step? You write out the equation for both species that is undergoing the dissociation, okay, in water. Because when we are talking about the relative acidity, we are comparing it in water, okay, and in the same concentration. Then, if you know that usually the question will tell you this is more acidic than the other one. So once the question says this is more acidic, for example, if the question tells you this is more acidic than this, immediately you will know which conjugate base is more stable. The bottom one or the top one? The bottom one, okay? So if question tells you, if they give you the information, usually they will give you pKa. Alright, I'm not going to introduce that now because that is introduced in ionic equilibrium. If they give you information such that you can conclude that this is a stronger acid, it just means that this one is a more stable conjugate base. And therefore, you explain why this one is a more stable conjugate base, okay, using those three factors. So it's always either this, or this that you can use to explain why is it more stable. Alright, then after that, if it's more stable, therefore, the relative, its acid will be a stronger acid than the other one. Okay? So this is a correct answer. Okay, this will get full marks. Okay. You all know you have to copy already, right? Okay. Now I want you to think. If now I change the acid, I change it to Okay, no. Okay, if I change this to this, okay, means I compare this with this, how will my explanation be like? I give you 10 seconds to think. If I change this alcohol to this, compared with this, how will your explanation change? Which part of your explanation will change? You will use electron donating group? What is this? Is this a phenol with a benzene ring with the substituent inside? No. So, can you use the same reasoning as just now that one or not? What is the difference between this and this? If I plus H2O, what will I get? My benzene ring will stay, right? Then CH2O minus plus H3O plus. So this one, will there be overlapping of orbitals of your O with the benzene ring? No, why? Very good, because the O is not directly bonded to your benzene ring. But this one, it is directly bonded. So can I use the same explanation? Yes, I can, because it doesn't, unless this one also have the O that is directly bonded to a benzene ring, then both will have the same stabilization. But now this one, there is extra stabilization, but this one don't have the extra stabilization from the overlapping of orbitals. So therefore you can use. Okay? So can you copy this down also and say that this explanation is exactly the same as this, except that your conjugate base for your alcohol changes to this now. Alright? And therefore this one is a stronger acid than this. Yes? A conjugate base is just the pair of the acid. It's just a pair. So wherever you have an acid reacting with a base, there will be a conjugate base. Which means after it donates away the proton, then its partner, that one that lost a proton, that one is its conjugate base. Okay? So now, if I have then you copy these two compounds down. This versus this. Can you write down your explanation for that? Okay, you write out the two equations first. You write out the two equations first. When you plus H2O, what will you get? Plus, what is the conjugate base? Okay, I don't want to use COH because you will become CO minus also. Let's say we use NO2. Then this one, H3O plus, plus, CH2, CH3. O minus. Now, okay, once you have written down these two equations, look up. Okay, so my statement, I want you to think whether it's true or false. I can use the overlapping of orbitals between the p orbital of O with the pi electron cloud to explain for the relative stability of this conjugate base. True or false? Can you show me using your X-ray stick? I saw most false. Why false? Because both of these conjugate base, they have the O minus directly attached to a benzene ring, which means both of it will have the stability from the overlapping of orbitals. Therefore, you cannot use that explanation to explain the stability of the conjugate base. Understand? Okay, so what will I use to explain? The electron donating or the electron withdrawing group. Okay, so you can just use one, and what do you need to write inside? So for that one, you will write how your notes have written down. So if you write down the electron withdrawing group, so you can say electron withdrawing group, okay, this conjugate base has a NO2 group which is electron withdrawing. Hence, it disperses the negative charge on the oxygen atom and stabilizes. Will I write phenol ion? Will I write phenol ion? You will draw out this, okay? Stabilizes this ion, and therefore the acid strength, will you say acid strength increases if the question is compare this with this? You will just say that this compound, okay, number one, you draw out number one, is more acidic. Okay, I repeat, you will say that this conjugate base, you draw out this conjugate base, okay, you draw out this conjugate base has the NO2 group which is electron withdrawing, or has an electron withdrawing NO2 group. Okay? Therefore, it disperses the negative charge on the oxygen atom. Hence, stabilizes this ion, which makes this acid more acidic than this acid. Okay? Okay, can you write that down now? Acidity is always tested in A-levels, so you must make sure you know how to explain. Okay? Okay, what questions do you have for this? Anything that you need to clarify? No? If I'm talking about this being less stable, then what must I say? Which one is the electron donating group? So the CH2, CH3, so this ion, what? has an electron donating group. 然后 then after that you can put the CH2 CH3. Then after that, which intensifies the negative charge on the oxygen atom. Okay? Therefore, it destabilizes this ion and is less acidic acid as compared to this. Okay? This one less acidic than this. Oh, you don't understand? Never mind, it's okay. I think Isa won't understand the laughter also. Okay, let's continue. I'm too used to it already. Okay, so now I have 10 more minutes. I will just go to this part. Can you go to page 17 of your lecture notes? There will be a quiz on all the reactions for alcohols on Thursday. Okay? On Thursday. Why are you so... Okay? Your quiz on all alcohol reactions on Thursday. Please go and study. Alcohol. So actually just now that game, so it's fun or not fun? Because so you want me to make more reactions to add to it for you to play? Because it requires a lot of work. If it's not fun for you all, then I won't make already. It's a lot of time on my side. No, but you must still sit for the quiz, okay? Okay, then I will, if I got time, I'll go and make, okay, the cards. Alright, so, esterification. So for esterification, what did you learn previously? Alcohol plus acid give you ester, correct? And what is the condition needed? Con H2SO4 and then heat under reflux. This is very important. You need to know is heat under reflux for esterification. Okay? I repeat again, for esterification, you cannot just put heat. I know sometimes heat under reflux, if you don't want to memorize, you just put heat. But for esterification, you cannot just put heat. It must be heat under reflux. Alright? Okay, so now you are going to learn another esterification. Other than that, you still know another method to form ester, right? Which is? Using alcohol plus acyl chloride, then room temperature will also give you ester, correct? So this one must plus H2O, this one plus HCl. Then this one is at room temperature. Okay, very good. So now you will learn another method to give you an ester. So if you look at this one over here, this one is reacting phenol with acyl chloride. Okay, to give you the ester plus HCl. But in this reaction, if it's just like this, the reaction will not work. So why is it that the reaction will not work, but for alcohol and acyl chloride, the reaction will work? What is the difference between number 1 and number 2? So it is alcohol and phenol as the difference, correct? So why is it that for number 2, if it's at room temperature, the reaction will work, but will work very, very slowly? It's because of the benzene ring then, the overlapping of the p orbitals, right, of the oxygen with the benzene ring. Okay, I must make sure that you know this concept. So it's because of that, that's why your phenol is less reactive than your alcohol. Therefore, your alcohol, because it's more reactive, at room temperature, it will already react with your acyl chloride. Okay, but for phenol, due to the overlapping of the orbitals, it is less reactive. Hence, for this reaction to work, you must have NaOH aqueous. Okay? So what happens when you add NaOH aqueous? So sodium hydroxide is a acid or base? Base. Then just now we learned that for phenols and alcohols, they can act as an acid or base. Acid, right? So we talk about acidity, right, of phenol and alcohols. So when you have acid and you have base, what will happen? It will react, okay? So when you have this, then you plus NaOH, it will give you O minus, okay? Then the Na plus is inside the solution mixture, it's just floating around as ions. So this whole thing is one ion, this Na plus is another ion, and they are surrounded by what? They are surrounded by what? Are they just this ion on its own floating around? They are surrounded by water molecules. That is your enthalpy change of hydration, right? So the ions, all ions are surrounded by water molecules. You see the linkages between concepts of. So now, this one, when you have this, what will happen? It can react with your acyl chloride, okay? And because you add the NaOH, you form your phenolcyte ion, and phenolcyte ion is now more reactive to react with your acyl chloride because as compared to your OH, which one is more electron rich? Which oxygen is more electron rich? The phenol one or the phenolcyte ion? The phenolcyte ion, correct? Because for the phenol, the electron is still shared between the O and the H, okay? But the phenolcyte ion, all of the lone pairs, it belongs to the O already. The extra lone pair belongs to the O now. So it's a stronger nucleophile, okay, to go and attack your acyl chloride carbon, okay, and therefore give you the ester. Okay, so because your phenol is more stable due to the overlapping of the orbitals, therefore if it's just phenol reacting with acyl chloride, the reaction will be very, very slow. Okay, because the oxygen is not electron rich enough, hence it's a weak nucleophile. But if you add some NaOH inside, it will deprotonate the H, means it will remove the H. Okay, it will cause your phenol to lose a H as H+. Then you will form the phenolcyte ion, which is a stronger nucleophile to attack your acyl chloride and hence give you the ester. Okay? So when this happens, again, this one is not in your syllabus, but this double bond will go to the O, then you will come back and the Cl will be eliminated. Okay? Then eventually you will just have O. You can see that O is forming a bond with which atom? Central one is who? If I don't put it down, if this is a skeletal structure, means the central one is C, correct? So, because my arrow points to the C, it means that O is forming a bond with the C. So can you see that it is actually O, then double bond O? So this one is the, what functional group? Ester functional group, okay? So this is an ester functional group because the O is attacking the carbon, hence it is forming a bond with the carbon, alright? So this one, the main concept behind it is because of the reactivity of phenol. Okay, so can you highlight whatever I've highlighted? Okay, the substitution one I've already mentioned at the start of the lesson. It does not undergo substitution using all these reagents, your hydrogen halides, your PX3, PX5, or your SOCl2. Okay? And therefore, you can actually use PCl5 and SOCl2 to differentiate your alcohol and phenol because phenol does not undergo substitution reactions. I'll get pimple, you know, if I look at this for too long. Yeah. Yeah. Because the light is not good for face. It's not good for skin. Okay, done? Okay, I give you 30 seconds. Can you look at it? and digest whatever I've said plus whatever is on your notes. I think still got a little bit. Okay, can you continue to highlight in this box? Okay, continue to highlight in this box. Okay, the oxidation one. When it's in a benzene ring, okay, look up. When it's in a benzene ring, what does it mean? This carbon, and this, okay, this carbon got how many bonds now? When it's in a benzene ring? Got 4 bonds because one of either this bond or this bond is a double bond, correct? So it's a double bond. So in this case, if you have this, okay, if you have this, right? If you want to oxidize your phenol, what must happen? This carbon must become, or C that is bonded to OH must become C double bond O, right? But if it wants to form a double bond O, what must take place? One of the double bond must break in order for it to form a double bond O, correct? So if it breaks this, will I still have the benzene ring with a ring inside? No, it will not be a delocalization of these 6 pi electrons anymore. Okay? That's why it says that it resists oxidation because it will lose its aromatic stabilization. The aromatic stabilization is just the benzene ring, the 6 pi electrons being able to delocalize. Okay? So, aromatic stabilization is just the delocalization of these 3 double bonds. Okay, of these 3 double bonds forming the resonance structures. Okay, so that is aromatic stabilization. Aromatic just means that it is 6 pi. There is 6 pi electrons there. Okay, so for benzene ring, the 6 pi electrons is by the 3 double bonds. Alright, so there is the stabilization because these 3 double bonds, they can delocalize. Okay, and there is 6 pi electrons. There's still 3 double bonds inside. So if there is no longer 3 double bonds, then it will lose its aromaticity. Okay? So there is a formula for aromaticity also, but that is out of your syllabus. Okay, so therefore your alcohol, because of the partial double bond character, the overlapping of the orbitals, hence your phenol is less reactive as compared to your alcohols. Okay? Okay, so now I need you to take down the criteria for success for your mind map. Okay, can you write it down? Don't take picture. Write it down. So your mind map needs to include all reactions of phenol. You use your lecture notes to come up with the mind map. The reagent condition of each reaction, just like how I did for each of the arrows, you write down the reagent condition for that reaction. You name the type of each reaction, you use a box to name, same as my mind map. And then if there is any observation, write it down as well. And for a possible distinguishing test, asterisk it up. Okay? You know what is asterisk, right? Yeah, the star. Oh, I realized. It's inverted. So whatever Iza see is inverted. Put a mirror. Okay, I want this on Thursday. Okay, I want this on Thursday. So Thursday, what do you need to give me?
This one.
The mind map, and then you need to study all the reagent conditions for alcohol functional group, and then means the alcohol mind map you need to go and memorize. And then what else? The tutorial, that 2 questions I will go through. Anything else? You will need to make sure the chemical energetics. I'm going to test you on chemical energetics. I'll give you a quiz on chemical energetics. So you must make sure you know. But I haven't given you back, right? Today is what? Today is Tuesday. I give you back on Wednesday. But I need to mark by today. Huh? Haven't copy finished. Oh, your teacher is out already. It's here already. Oh, you haven't copy finished. Okay, you take a photo. Thanks for being so considerate. They don't want a test, so they ask me not to hire myself.